Next up, we have amateur satellite secondary payloads from our VP of Operations and a Board of Director member, Drew Glassbrenner.
Push to talk. There we go. If you're of a certain age, you'll recognize this as a generic presentation. This means I finished it this morning to fill a gap. So I wanted to point out that I see this more as a discussion. The idea here is I'm also on the IARU satellite coordination panel. So anybody that coordinates their satellite, and it should be everybody, I get to see what frequencies they're using and what their missions are and whatnot ahead of time. And often a lot of these are educational based satellites. Some of them aren't even really amateur. They're Part 5 using amateur spectrum. And quite often we have the opportunity to nudge, drag, pull, push, shove satellite builders into having an amateur two-way secondary payload. So when I say secondary payloads, I really mean two-way secondary payloads. Let me figure the mouse out here. So just for this discussion, I'd like to define secondary as either a hosted payload on a satellite belonging to a separate entity, and we've got lots of examples of these in the history of amateur satellites. Just a few of them off the top of my head. RS-12 and 13, 10 and 11 for that matter, were Russian payloads hosted on Russian geodetic satellites, very large satellites, which was good because those used 10 and 15 meters and had plenty of room for a big antenna. AO-27, the repeater on AO-27 was a secondary payload on a satellite called ISAT. PCSat-2, I think you might be able to define as secondary, got stuck on the side of the ISS for a little while. SO-67, Sumbadilla satellite, maybe some of you guys remember that one. It was an FM repeater payload on a South African telescope, Earth observation satellite, telescope but pointed down. And probably the most well-known one now, at least in certain hemispheres, is QO-100, which is a secondary payload on a TV satellite. So we've got a long history of those. Another version of a secondary mission, by my definition, and I'm talking so I get to define it, is the use of a satellite, either command and control or telemetry radio for a two-way mission that is secondary to the primary mission of the satellite. And we've got some more recent examples of these. Some of them have become very popular. There's a French university that has now launched, or French organization has now launched two satellites that have space weather sort of primary science missions, but they're educational, UVSQ-SAT and Inspire-7-SAT. Both of those use the ISIS space crossband command and control radio, which happens to have the option, if you choose it when it's ordered, to operate as a VHF up, UHF down FM repeater. So in both of those have run those repeaters. Probably the most notable one of this subclass of secondary missions would be IO-117 or Green Cube. If you haven't heard about Green Cube, let me tell you, you're missing out. This was a 3U Italian satellite, educational satellite, that was launched on a Vega launch. The primary mission was a big reflective mast ball, basically, and it was a follow-on to a previous mission where they tracked it to be able to do optical observations as to rate of decay. So the interesting part is it went to a MEO orbit. It's at 6,000 kilometers. Typical LEO these days are 550, 600 kilometers. ISS is 400 kilometers. So what that does is it takes your footprint from half of the US to half of the hemisphere. And since this is a generic presentation and images are extra, you'll have to look that up on your own to see the footprint. But it's impressive. Personally for me, from Florida, I've taken my DXCC count from 110 to 138 based on this satellite. So it's something to take note of. And the secondary mission on that was done at the suggestion of IARU. So we can make an impact in getting these missions operational. So benefits of a secondary mission as opposed to a primary mission where AMSAT or another entity builds and launches and operates their own individual satellite. With secondary missions, a hosted payload lets us focus on RF. Yeah, we still have to do some thermal work. You know, it depends on what we're flying on, but we're not worried about attitude control. We're not worried about propulsion. We're most importantly, and growing in importance, we're not worried about orbital debris. That is the main payload's problem. We're just a little barnacle hanging on. So we go where they go, and they have to do all that paperwork. Could be simplified operations. I've been the command station for several satellites, beginning with AO 51. 51 in particular, I basically was on it every day, every other day, adjusting the power levels. That was the big thing, to maintaining the satellite, uploading schedules, changing modes. A hosted payload or a secondary mission payload could have the benefit of, hey, we're going to turn it on and we're going to turn it off. And if we can't turn it off and something happens, then at the other end of that power line from the host satellite, they turn it off. So there's a little less responsibility and a little easier go of it. So what benefits for the host? The host can benefit from a backup telemetry source and possibly a backup command capability if the primary mission aligns with the amateur satellite service. So what we can't do is fly a amateur radio payload on a commercial satellite and use the amateur radio spectrum to do anything that would have pecuniary interest with that satellite. But if a university is flying a satellite and they've got their radio on one end of it, say it's a 3U or a 6U or something like that, they've got their radio that they're using for their telemetry and their command and control, and we're on the other end of it, and we have access to their IHU, to their computer. If something goes bad with their radio, they have the opportunity to use us as a backup, to send a fire code to reset, to get telemetry down, to do, however you set it up. But the important part is that the primary mission to do that has to align with the amateur radio service. So no commercial backdoors. The host can benefit from a public relations boost if we do something STEM related. The host isn't really going to get a whole big boost just because a bunch of gray hair guys like us want to talk to each other through their satellite. But if we do something innovative and something that involves the kids and gets some sort of STEM boost in there, like what Frank was talking about earlier, that's a public relations boost for our host. So that's a potential benefit. With benefits, there's always drawbacks, or as some people like to call them, challenges. We have to convince the host, are we really worth the hassle? There's extra work that has to be done to integrate a secondary payload. There's, in some cases, mass equals propellant, and the more mass they're carrying, the less propellant they can carry for station keeping. I'm talking like a GEO sort of hosted payload, and we're definitely cutting into the bottom line there. Or perhaps the payment's sufficient to get them to overlook that. Schedule. Schedule is probably the biggest challenge of all of these. Commercial space these days runs very quickly. In the past, when we launched some of the first Fox satellites, we had 1-2 year lead times between the time, I'm talking in particular the two that we launched with Space Flight Services. We signed the launch contract and it was a couple years before we were getting to launch. These days, if you've got the money and you've got the license in hand or can get it in hand, you can call up and get on a transporter launch and they'll integrate you about 30 days before launch, sometimes less than that. So if you find an opportunity, you have to be able to jump on it lickety-split, or you might be waiting for the next one. Of course, we're not paying the bill, so we're going to have lower priority with regards to power. And if power is a problem, we're going to have lower availability with regards to scheduling. Are we going to be able to be on all the time? If we have to have our host do anything for us, you can bet we're going to be at the bottom of the list. So that could be a challenge. Reusing command and control radios for a secondary mission has a whole extra set of issues. And I'm going to talk about a little bit of inside AMSAT baseball, and maybe Jerry might want to put your fingers in your ears. It's pretty well known by now that the Fox satellites shared, our command uplink was also the user uplink. So that's fine when you've got a command station like me down in the corner of the continent in Florida, and most of the time I'm looking out over ocean and maybe Puerto Rico and a couple of Caribbean stations. But it can be a real problem if you need to send a command to your satellite and all the amateur radio guys don't realize that the transmitter's off and they're all jamming your uplink trying to work a new grid square. That's a real problem. It can be overcome. You overcome it with gain. You overcome it with watts, late nights, and like I said before, having a geographic advantage and doing your commanding when nobody else is around. So just some typical secondary payloads. There's possibility for other things, but these are the three that we see most often in the order that we see them. Digipeaters, FM repeaters, and transponders. Sometimes you'll see people call an FM repeater a FM transponder. I like to keep it simple and use different words for different things. A digipeater or a store and forward system, I lump those together because usually if you have a store and forward system, it'll digipede also. A lot of times with the IARU work, we see these proposed as using the command and control radio. So you're tied to whatever format they're using, and there are a whole host of people building radios for CubeSats. And they run the gamut from very sophisticated and very flexible to something that looks kind of slapped together off of something you found on the internet. And they sell these. So a lot of students end up, student organizations and universities end up with a whole spectrum of radios and formats. So a lot of times you get something that's not common in the amateur radio community. 2 GFSK, something that we don't see a whole lot. We're kind of set in our ways with 1200 baud AFSK and G3 RUH or GMSK 9600 and higher. That's what we like to see because that's what we all have equipment for. But a lot of these digipeater missions don't use those. So another one that we see quite often is, again, leaning on the IARU experience, is that you'll see a mission that proposes a 9600 baud or a 19.2 downlink or sometimes even higher, and you get down to the section of the coordination application and there's what's your ground station? Tell us your ground station and show us that you've done a link budget for your ground station. And in the ground station they'll have listed ICOM IC 9700. Well, as anybody that has a 9700 that's tried to work digital knows that it doesn't do 9600 baud. It's not supported. Why ICOM did that, I don't know. It barely does 2400 baud. GreenCube recently ran a few days in 2400 baud, and it would receive it fine, but you were lucky to have enough bandwidth to get that 2400 baud signal through without getting clipped at the edges and decoded by the satellite. So if you want people to use your digipeater, and typically when we're sending digipeater messages, it's what, 20, 40, maybe 60 characters. Do you really need 9600 baud to swap a grid square or a high or whatever? So that's a consideration to take into account with the digital secondary missions. Luckily, we're not all tied to hardware TNCs anymore, and we haven't been for quite a while. I'm going to mention UZ7HO. I've never met him. I've corresponded with him. He writes some awesome sound modems for free. He puts them on his website. You download them, and suddenly you're working this, excuse the expression, weirdo modulation format. And then he even a lot of times has clients for the other end of it, so to put your messages in. So it doesn't have to be complicated. It can be, but we have solutions now. And IO117 is the best example of that. When that was launched, the prescribed method of generating a signal for it is GNU radio. And as I expressed at some point in the last day or two, I'm a geologist. I passed the first calculus class, and that was it. So GNU radio is tough, especially if you're not running it on Linux. It's tough. But UZ7HO wrote a beautiful sound modem for it, and now there's hundreds of users around the world on this satellite because of it, and it's easy. So along the same line of thought, the popularity is directly proportional to how common the format is. If you want a lot of people to use your secondary mission, use a commonly available format. And the other direct correlation to popularity is orbital height. With IO117 at 6,000 kilometers, it's the highest thing we've had in a long time, not counting the lunar mission, and it's great. And I guess you would say the reverse of that is if you're with an organization that lucks into a high orbit launch or a medium orbit launch, reach out, put something on there. That is a scarce resource. Take a quick drink here. The second most common secondary payload we see is an FM repeater. There's also a long history of those, like I mentioned in the beginning, 2767. PO101 is a Filipino satellite that has an amateur radio unit on it. It's active just about every day via schedule. It's a great satellite. Very popular. You may have your own independent feelings about FM repeaters. You cannot deny that they are popular because they are jam-packed no matter what time of the day. We could put 100 FM repeaters up and they would still be jam-packed all of the time. There was just a launch of 8 FM Israeli student satellites, the Tevel series, and they all have FM repeaters on them. They're all in the same orbit stretched out, and they're busy. Very, very busy. There are 2 or 3 or 4 of them on at a time, and there's always somebody there. Repeaters can be the command and control radio, like the UVSQ-SAT and Inspire 7-SAT, but they can also be a separate radio like AO27 or SO67. That's going to allow the operator to run it more often, not always have to be on a schedule. The schedules are kind of difficult to get the word out because people expect it to be on. Maybe, to borrow a phrase, a low information user might not know that it's on a schedule and might be disappointed that they can't hear it or can't access it. So if you have a separate radio and you have enough power, that generally takes care of that. You just run it 24/7. But the other side of that coin is that if you're using a command and control radio to run your secondary mission, it's already there. It's a free. It's bonus. It's do not collect $200. So the ISIS-based radios are the ones that are quite often used for that. They sound very good. They work well. There's a few issues. They use a RSSI-based access, so you have to have a certain signal level to get in it. And depending on where that signal level is set, that may exclude some of the smallest stations, but it also saves power for the satellite, so that can be important. But you have to ask, you have to click the box when you order it to get that repeater functionality included in it. Back to the schedule, ideally it's on 24/7. Maybe it's on part-time until the primary mission's done, and then it's turned on 24/7, but that works the best. Access, either via a carrier-operated system or an RSSI-based system. Sometimes they use a PL system like we did with AO51 or SO50. That works well, and that keeps it from broadcasting to whales and penguins. So not as common, but certainly have been some out there, and certainly will be more in the future, are the transponders. Transponders as secondary payloads, again, the Russian satellites were probably the ones that a lot of us cut our teeth on because they were easy to hear, and we had HF equipment already. UCube-1 carried the FunCube-2 transponder. That was a secondary payload on that satellite. I particularly enjoyed that one because I worked my last grid in the United States on a 2 AM UCube-1 pass, so I was glad to see it was there. HuskySat carried HuskySat-1 carried AMSAT LTM, the linear transponder module. That was their primary radio, but of course the transponder on it was a secondary part of their mission, our primary mission, but their secondary mission. And the next one to launch with an LTM is MainSat, MESAT-1. Should be coming up pretty soon. It's been manifested. Launch. Yeah, it's up to Firefly at this point. Firefly had some issues, so they're doing the prudent thing and taking a good look, making sure they don't blow another one up. And the most famous is QO100 with both a narrowband and a narrowband transponder for sideband, narrowband data, and a wideband transponder for really cool things like digital ATV. And that's hemisphere-wide coverage on a TV satellite. Unfortunately, it's not our hemisphere this time. So, conclusion and some editorial opinion on my generic presentation. Long history of amateur radio as secondary payloads, as orbital debris, collision avoidance, location reporting, and other issues become more complicated to manage. Perhaps additional focus on secondary opportunities would be fruitful. That was as kind as I could write that. Ready off-the-shelf payloads, easier said than done, but are ones that are easily adapted to the host power and space requirements enable us to do this more efficiently. And also, I'm open to ideas for other payloads. We've got another 5 minutes, I think, so I can take a couple of questions or ideas or discussion.
That's right. We have your first question back here.
Hi, Drew. This is a question with respect to what Frank was talking about with the SFCG and the protection of frequencies on the moon. I'll start over. Dovetailing back to what Frank was talking about with the protection of frequencies on the moon and especially in the amateur 2 meter, 70 centimeter portion. Do you think that IARU would have any part in that as that starts to become laid down in the approvals?
So
coordination?
It's definitely an issue. I'm a panel member. I'm the guy who collects the carts out of the parking lot and mops the floors after the business is closed as far as IARU goes. I will bring it up and discuss with Hans, the satellite coordinator. We have coordinated 3 lunar missions. One has launched and is now complete. The other one, I don't remember if it was a launch failure or a satellite failure, didn't launch at all. And then there's the third one that Paul mentioned, the Lunar Oscar 2, which was coordinated a few months ago, I think it was. So we're going to bring that up. I'm going to bring that up to Hans, and we're going to discuss it, and along with the panel. And we will certainly reconsider our how we handle lunar coordinations off of that. Any other questions, ideas, comments? Rotten tomatoes? Awesome. Thanks.